Hello, we are discussing about GATE 1991 ECE paper, and the topic we are discussing is electronic devices. This is 8th 1 mark question came in GATE 1991. Look at the diagram. In the figure, the input Vi is a 100 Hz triangular wave having a peak to peak amplitude of 2 volts and an average value of 0 volts. Given that the diode is ideal, calculate the average value of the output V0 is. For the given circuit, if the input is peak to peak triangular wave with 100 Hz frequency and magnitude of 2 volts peak to peak. If the diode is ideal, calculate the average value, that is DC value of output waveform. Answer for this question is 0.3 volts. Average value of the output waveform V0 is 0.3 volts. Now we'll see how to solve this one. Given diode is ideal, input is 2 volts peak to peak triangular wave with frequency of 100 Hz and 0 DC. DC value is 0, frequency is 100 Hz. Frequency 100 Hz, we can calculate time period from this information. Time period is 1 by f, that is 1 by 100, which is 10 milliseconds. So we need to calculate the average value of the output waveform. This is the input waveform. So input waveform is varying between +1 to -1 with the time period of 10 milliseconds. So time scale is in milliseconds, and here we are indicating with 0, 5, 10. If this is the input waveform applied for this circuit, then first draw the output waveform, then calculate the average value of that waveform. Okay. So this is the input circuit given. If you apply the input waveform, given diode is ideal, during positive half cycle, all input voltages are positive. During positive half cycle, all input voltages are positive, so the diode is going to be comes into forward bias. Since it is ideal, a small amount of positive voltage which is greater than 0, diode comes into forward bias. So diode comes into forward bias and act as short circuit, so that V0 is equal to 0.6 volts. So during negative half cycle, all input voltages are negative, so diode is reverse bias and it is acting as open circuit. If the diode is acting as open circuit, the equivalent circuit diagram looks like this one. Now output voltage is calculated using voltage division rule. So V0 is 1 kilo ohm by 1 plus 1 kilo ohm into input, that is half of input. So V0 is half of input voltage, but the polarity is negative, since V0 and V input are in opposite polarities. Now based on those two things, during positive half cycle, output is 0.6 volts. During negative half cycle, output is half of input voltage. So this is what we are going with. This is the output waveform. During positive half cycle, it is 0.6 volts at, and during negative half cycle, this is the output waveform. So we can write output equation as V0 is equal to 0.6 volts during 0 to 5 and minus 1 by 5 into t minus 5 when the time is between 5 to 7.5. This is 7.5 this is okay, and it is this equation. This is a straight line, this is one more straight line. So this straight line is going to be giving the equation as 1 by 5 into t minus 7.5 whenever time is in between 10 to 7.5. So the output equation expressed as 3 segments. First segment is constant voltage of 0.6 volts. Second segment is negative going straight line whose slope is negative, and third segment is nothing but positive going straight line, that is with positive slope. So 0 to 5 it is constant with 0.6 volts, 5 to 7.5 it is having negative slope of minus 1 by 5 into t minus 5. This is the equation. And for this third segment, positive slope, that is 1 by 5 into t minus 7.5. So this is the output equation we can write. The output equation for these two segments can be written by using straight line equation between 2 points, x1 y1 and x2 y2. If they are going to be 2 points, then the straight line equation can be written y minus y0 is equal to y2 minus y1 by x2 minus x1 into x minus x0. This is the equation used to get those output equations for those two straight line segments, that is to get minus 1 by 5 into t minus 5 and plus 1 by 5 into t minus 7.5. Now we need to calculate the average value for this one. Average value of v0 is equal to 1 by t integral 0 to t v0 dt. This is the equation for the average value. Average value can be calculated by going through the area of output waveform, dividing it with time period. So integral 0 to t v0 dt is nothing but area under the v0, and it is dividing with 1 by t to get the average value. So t is nothing but 10 milliseconds, so we are writing it as 1 by 10, 0 to 10 v0 dt. So v0 we have 3 segments. Those 3 segments if you insert at that time, this is going to be the equation 1 by 10, 0 to 5 separate v0 which is 0.6 dt, 5 to 7.5 negative going slope minus 1 by 5 into t minus 5, positive 7.5 to 10 it is positive going straight line, so 1 by 5 into t minus 7.5. Solve this equation. So constant integration is t, and t integration is t square by 2, and again t integration is t square by 2. So if you solve this one, it's going to be looks like minus 1 by 10 into, this is minus 1 by 10 into 2.5 whole square, 7.5 minus 5. Okay, and here also 10 minus 7.5, it is also exactly you are getting 2.5 whole square. So this term and this term will both get cancelled. So what you are getting is 1 by 10 into 3. So 3 by 10, which is nothing but 0.3 volts. Average value of V0 is 0.3 volts. So the required answer is output voltage DC value of the output waveform is 0.3 volts. Thank you.